to check with you all. Can you all hear me clearly? There's a checkbox at the bottom right corner. Yeah, please comment if you can hear me loud and clear. Okay, great. Let me walk through the agenda with you all for today. We have speakers from Baumer and Pilz to share about how you can achieve smart and safe technology in today's electronics industry in one solution. Next, Q&A and survey will open to all after the presentation ends. A recorded version of this webinar will be sent to your registered email address after the event. Before we start the presentation, I would like to introduce both our speakers. Our first speaker, Mr. Thomas Wong, is the sales manager from Pilz Southeast Asia. He mainly oversees sales in Singapore as well as Philippines and Indonesia. He is a certified machine safety expert with good knowledge of safes, automation, robotics, and machinery safety. Furthermore, he has achieved many key milestones throughout his career in the machinery safety and electronics field. His passion for safety motivates him to strive towards achieving safe human and machine collaboration beyond Industrial 4.0. Next, I would like to introduce our second speaker, Mr. Augustine Goh. He is the head of sales from Baumer, Singapore. He has 10 years of experience in factory automation, and he has lead product management and sales function in Baumer for several years. Over the last 2 decades, he has actually implemented various vision-related projects across various industries. So without further ado, let's welcome our first speaker, Mr. Thomas. Thomas?
Hi, good afternoon, good morning, and good afternoon. Okay, I'm actually the sales manager as introduced for Pilz Southeast Asia. So today I will actually touch on the path to electronic and semiconductor machine safety. Okay, just to give a bit of a Pilz background itself, our vision is to become the global suppliers of automation products, systems, and also services. And our mission is we automate safely. We are founded in 1948 as a glass blowing workshop. However, we move on to the electronic sectors afterwards when there's a bloom in electronic sectors. And our HQ is actually at Ostfrieden. In the background, unfortunately not very clear, you can actually see the campus of our HQ itself. And this is located in Germany itself. And our turnover is actually Euro 332 million. We have 42 subsidiaries. So what is subsidiaries? Subsidiaries is actually a company like Pilz Southeast Asia. This is considered as one subsidiary. So we have a total of 42 subsidiaries and up to 2,500 employees worldwide. And we have R&D quotas of 21%. So we do a lot of research to develop new products. And of course, we export most of our products worldwide. Okay, as you know, we are safety experts. So safety is our core competency. So we do have obligations to provide safety all over the world. And we do collaborate with over 50 standards committee worldwide on safety itself. And I believe you will know some of this, like IEC, ISO standards, to your UL and CE, and even TUV, which is the commonly known. Okay, through the years, we have been a market leader in innovative technologies itself. Like in 1964, we created one of the first timer, a mercury relay. And in 1987, the world's first safety relays, PNOZ, is created by us. And in 2009, the first automation system for safety and automation. This is a PLC system, integrated safety. Okay, for Pilz Southeast Asia, we're actually based in Singapore, German Center itself, near the International Business Park itself. We are actually opened in June 2016. So we are only 5 years plus old, very new company. for this Southeast Asia side. We operate in Singapore, Thailand, Malaysia, Philippines, Vietnam, Indonesia, Cambodia, Myanmar, and even Laos. We have a total of 23 staff located in Singapore, Malaysia, Thailand, and Vietnam. And we also coordinate global service projects with the International Service Group. So we don't only do local projects, we also do international coordinated kind of projects. As you can see from this picture, this is our opening ceremony. Okay, let's go straight to the popper. Nobody should be in the statistics. As you can see from this slides itself, in first quarter of 2021, you have already 38 major injuries, as you can see from this, and 3 fatal injuries just from the manufacturing sectors itself. And for machinery incidents, there's 16 major injuries occurring just in the first quarter of 2021. And actually in the fourth quarter of 2020, we have actually 19 and actually 1 fatal injuries occurring from this. And from statistics 2020 Singapore, there's a compensation of Singapore 74 million for these 16,000 cases. And we do know that one accident is one too many. So our objective is actually to reduce it to almost 0, if possible. Okay, so how do we do that? How do we go to this safe machineries, automations? So we have a lot of hurdles, as you can see here. So we need to go to the first and most important hurdle of all, which is your risk assessment. So after you have done your risk assessment, you can go on to the safety concepts to design out what kind of eliminate the risk itself, and then designing the actual system itself, and followed by the validation of it. You validate whether is the risk properly addressed and reduced. Followed by, you need to conform to your regulations and all your UL or CE markings regulations itself based on that. So let's move on to each of them. The hurdle 1, your risk assessment. So the risk assessment must give attention to intended use. So this is usually for task-based like teaching of robots, teaching of machineries, doing maintenance, settings, cleaning, etc. So it's not only just operator doing your normal operating, it's also depending on the task, other tasks that's involved. And of course, we need to take note of the unexpected startup. And we also have to make sure that we need to take note of the access by personnel from all directions. Example, you have electronic machines that has an operator sitting there and working on the product itself. However, you need to take note there could be people accessing from the side of him or behind him and all this. So we need to take note of all the risks from all directions. And of course, any reasonable foreseeable misuse. Let's give an example of a machine that has a light curtain installed. However, if the machine have a step by the side of this machine, the person could step on this and reach over across to the dangerous zone. So to eliminate this, we could just remove the step that is actually built into the machine itself. So this is one of the ways. Okay. And to take note, risk assessment can be started when the machine is in the design stage. Actually, it's actually the best to do in the design stage. Reason is because you can eliminate or build your system safely from the start. And this could eliminate a lot of additional costs to implement new or different kind of safety measures for this machine itself. So it's always recommended to do in the DRA stage. And risk assessment has to be repeated if there is any modifications of the machine or even change of environment. So meaning that if a machine is moved from one place to another place, you still need to do a new risk assessment instead of following back the old risk assessment. And to take note, electronic and semicon machines that's following this SEMI S2 must go through risk assessment to determine their risk level. So this is based on ISO 12100. So to take note, this is roughly how one of the charts might look like. So this is the likelihood of any injuries itself and how severe it could be. So by going here, you are almost certain to get injured, and it's catastrophic, so it has the highest rating, to your minor, which is you got a low injury, which is quite rare. So this is a green zone, meaning this machine is quite safe. Okay, the second hurdle, safety concepts. So we have a few risk reduction measures that can be implemented. So one, inherent safe designs. So by doing a good safe designs, you actually eliminate the risk or reduce the risk itself. Some of the ways is to increase the distance from the hazard, like as having a conveyor belt to deliver the items to the machine instead of a operator putting the product in. Another way could be a modified design. Example, if the design was using of light curtains or something that is too close, that should not be using it, like such a machine of a semicon. So they can actually have a design of an enclosure to make sure that it's safe and prevent people from accessing it. Another way, there could be technical safeguards. So there's safety functions like guardings or SRPCS, which is your safety related parts control system, and also following EN ISO 13849, looking at the performance level of this safety components itself, and then 10218-2 for the robot system itself, which is normally PLD and Cat 3. So you do see some designs here for the guardings. This is enclosed of a robot, and of course we do have some like door switches, non-contact door switches to your e-stops, to your safety controllers, and the scanners and all this that can be used to actually provide the technical safeguard. And the last but least recommended should be your information for use. However, if there is no way to reduce the risk, you have to put in somewhere so they can have residual risk in your operating manual instruction itself. Or you can provide to your employees personal protective equipment like PPE such as this, or having some pictograms like crossing hazards and all this to be labeled there so they can be aware of this danger itself. So the next one, we are looking at the human-robot collaboration according to 10218 and also ISO 15066. So for this, there's a few ways for human-robot collaboration to work. One is by using a safety-rated stop. So once you go in the zone, it will shut down the robot or turn it to stop. And the next will be your hand guiding using some enablers, whereby you will actually make sure that it's safe, that you can actually touch this with an enabler on using in the other hand. So there is two that is more popular now, which is your speed and separation monitoring. So this one I'll touch on slightly more later. And also power and force limiting, which we'll also touch on slightly later more. Okay, for this speed and separation monitoring, as you can see, there's different zones of different speeds. So example, a person is walking into a danger zone itself. The yellow will be whereby you slow the machine slightly, okay, and then followed by your orange zone, another step further, and lastly to your danger zone, whereby they will actually push it to a very low operating speed itself. So this is one of the methods. The other methods is actually, the other one is the fourth method, which is the power and force limiting. So this actually allows collision to happen. So you can allow you to bang into the cobot itself. So however, take note, this has a limiting of the power and force itself. So there is a way to measure this. And later on, we will touch on that as well. Okay, so do you have a hurdle tree? So which is your safety designs. So most designs is based on ISO 13849. So this is where you actually measure your performance level to measure the ability of the system to perform a safety function under foreseeable conditions. So what this means is that if the machine is more dangerous or more higher risk, you need to have a better safety system to actually protect this machine from malfunctioning or having breakdowns, so that you can protect the person involved. So do take note, electronic and semicon machines are actually referring back to this ISO 13849, so they must do this kind of safety designs. So let's look at one of the ways to look at how to measure the performance level. So S is your severity of the person injured. So example, this is a dangerous, you can chop your hand or injure your one limb. So you actually is severe. And then this is F is the frequency. So if let's say this is not so frequent, you only do it in maybe 1 year once, the frequency. So we actually put it to low, which is this F1. This is F2 is high, okay, which is maybe daily occurrence. And then probability of this occurring, can it be avoided? So P1 will be you can avoid it, and then P2 is your you cannot avoid it under any circumstances. So you actually, let's put it this way, if ours is actually P2, so you can't avoid it, so it will be a performance level D, minimum requirement for your system level. Okay. Okay, so for the performance level is a discrete measure to measure the ability of the system to perform the safety function under any foreseeable faults. So it means that it's the reliability of the safety control system itself. So there is a few ways also to do this kind of architecture. So it doesn't mean that you have the idea of it. So you need to design it out. So this is how you design it. So this is a cat tree, and this cat tree will be dual channel incoming, and then we have a to cut off. There has a communication between the contactors itself, and also there's a feedback to the contactor. This is considered a cat tree. However, for cat 4, which is the highest level, you will have a dual channel for the incoming, and then you will have two contactors with communicating to both to cut off. So in case, example, one contactor fails, the other one can still cut off. So this is how a cat 4 system will work. So this is almost a fail-safe system. And we do have a lot of software to actually do a measurement for this kind of Pascal or your performance level. So we have a software called Pascal and also a software Systema. So this is a Pascal report. So in here, you can see we have a sensors, and we have a logic, we have a contactor. So you can see that our sensors and our safety relays actually meets the requirement. However, from the contactor itself, it doesn't meet the requirements. So a bit hard to see, but here is a target level, performance level is actually D. However, we can only achieve C based on this, so it does not meet. So meaning we must change out the contactor to something that's more suitable, or a dual channel contactor. Okay, so we will move on to the hurdle 4 itself, is the validations. So validations includes post-measure risk assessment. So this is to measure your, after what you have done the risk assessment, you measure, is it meeting this? And then safety function assessment, which is your performance level achieved, and also your stop time measurement, this kind of measurements itself. And of course, we have to also validate the software. So this is software validations, which is your safety PLCs and your safe robots. And we do need to take note of the installation of safety relevance components. And if the safety system is modified, a validation is needed again. Please take note of that. So for this, you can see this is a safety installation and fault validation kind of a report from Pilz. So that's what we do. And also, how do you measure a stop time measurements for a robot? So we have a light curtain here. So a light curtain has a response time, and to link to a controller, there's some response time as well. And the safety controller also have a response time and link to your driver of your robot controllers. And lastly, to the robot, the stopping time of the robot. This whole thing is actually your stop time measurement. So we need to make sure the light curtain is placed a safe distance away from this robot that allows it to have time to actually stop before this person can actually reach to the robot itself. So this is what we call a stop time measurement. Okay, just now we mentioned on the validation of the HRC, human robot collaboration. So we do the last method 4, there's a collision allowed. So it's based on this ISO 15066. Based on this, they allow collisions. So imagine this is a robot arm. The robot arm on collision, it will activate the fail-safe limit robot when it reaches here, and it will definitely stop when the robots reach here. So this is the limit of the robot. So by this measurement, if it's within this threshold of this ISO 15066, it's allowable. So however, if let's say this measurement is higher or exceed this threshold, then you just need to calibrate to a lower level for the pressure and force of this cobot itself to meet the requirement. We will have a device data that I will touch on, which will show you how to do this. So just now, we just went through the safety life cycle. So from application analysis to your risk assessment, to your concepts itself, to your designs and also implementations. And also, we need to have some markings like C markings or UL or whatever certifications. And lastly, we need to make sure we also provide training and technical support as well. So this is the complete life cycle of safety. Okay, just take note that for this semicon machine itself, the Semi S2, so they are in reference to also our ISO or IEC standards. So IEC 6024-1 is one of them. And then we also have 12100 and also 13849 and 12218 also mentioned in this Semi S2 standards itself. Okay, so we have two questions. So one, we implement all safety measures, cobot, e-stop, safety sensors, guardings. Do we still need to do risk assessment? The answer is actually yes, because risk assessments is the starting of all measurements. So without knowing the risk itself, you will never be able to implement the safety measures. So we always need to do a risk assessment regardless of whether you are trying to implement any safety measures. Why do we need to use safety components? Is PLC and normal automation component not safe enough? The answer to this is yes and no. Okay, why no? No is because sometimes during the risk assessment, we assess that the machine is very safe. Okay, so by it being safe, because it's performance level A, we do not actually need to use any safety components. However, if we do a risk assessment, we found that it's a performance level D, and highly you will need to use a safety component because you could not achieve this with a normal PLC or normal automation component. Okay, so what does PILS do? We actually able to provide you some of these services. So this is one of the services we can provide, which is your design risk assessment, your risk assessments itself, your safety concepts, and also your validations. We are able to do all this, and even CE markings. We are able to do CE markings as well, and trainings. So we do have some trainings here. We got fundamentals of machinery safety. We got also risk assessment for your fundamentals. This is all the more popular course. For advanced, we do have the design safety designs like ISO 13849. So this is one of the popular course as well. And the most popular course will be your CMSE, your Certified Machinery Safety Expert course itself. This one is actually internationally recognized and issued by TUV NOT. It's not by us. Okay, for our product base itself, we have sensors technologies, your controllers, your drive technologies, your operating and monitoring systems, and also your software. Okay, let's touch on the safety door locks and some sensings. So we do have mechanical door locks and also magnetic door locks that's interlock, followed by your magnetic non-contact kind of switches, and also your PSEN code, which is your coded kind that's non-contact. Okay, we have all this. We will touch on more on this newcomer. This is our PSEN ME5. So this guy is one of our better sellers, and actually is actually having spring force and also magnetic force up to a 1,500 Newton of holding force itself. So this is something we are promoting. They do come with a lot of actuators, as you can see here, from your standard actuators, your radius actuator, and also we got escape release and also emergency escape. So there's a lot of accessories that it can be used on. And we do have some application stories for this ME5 itself. So my customer is actually building many low-level machines for electronic and semiconductor industries. So they've been using our competitor old brand for the door interlock for many years. So after testing our door locks, they're extremely happy with it. So what is the advantage? So there is a metal head. So this is the metal head as compared to our competitor that's using a plastic head. And of course, our PSENme5AR, this guy, is actually better functionality than our old actuators itself. And of course, lastly, the most important point is very attractive pricing. So if you are interested, to let us know. Okay, the next one will be light curtains. So this is standard light curtains itself. In the market, you will see a lot of Type 2 and Type 4 light curtains in the market. However, do take note, we are one of the first to come up with a Type 3 light curtains to cover the gap in between. So it's applicable to PLD, CL2. So this is actually suitable for robotic applications. So we have Type 2, Type 3, and also Type 4. So we have all types. So if you're interested to know more, you can contact us. And you can see from this light curtains functions, one of them is for robotics as well. So this can be using of PLD, which is Type 3. Okay, we have a safety scanners, laser scanners called PSENscan. So this is a 2D area monitoring system up to performance level D, Type 3. So operating range is 3 to 5.5 meters up to a 40 meters warning zone. So it's at a 275 degrees angle. So up to 3 zones, warning, protection, and reference zones, and also configurable up to 70 zones itself. So this is one zone. This is a danger zone. You can put it, okay? Or you can act as a light curtain. It's also able to function as that. And it can use for AMRs, AGVs as well. So this is just one of the functions. So this is a laser scanner. So this is the danger zone. This is the warning zone itself. So if the person was to walk in here, it will know that somebody is coming in. Once it reaches the red zone, it will actually stop. Okay, we do have some application stories as well for this. So my customer is building a complete solution for their end customers, a product manufacturing company. So they want to detect any person inside the robot operation zones or when they're walking to the stations when the robot is operations. There's some robots behind here that you can't actually see. So they have actually installed quite a number of scanners to protect this area to prevent people from standing there when the robot is in operations. So what they are using is actually our laser scanners and also our PNOZmulti too. Okay, just now I mentioned about the robotic measurement. So this is actually our Pilz robot measurement system, PRMS. So this is a collision measurement set for human-robot collaboration. So you can actually rent or sell this to you, or you can buy this, okay? So what it does is actually, you can record of pressure and force on this machine. So we will use this to measure and then scan it to the computer like this. And they can actually measure, is it within the range or out the range? So this is also based on the ISO 15066. Just take note, if the manufacturer comes to you telling you that the robot is safe, however, once you actually change the applications, example, when they do a measurement is for pick and place, you change it to something to insertion or different kind of applications, you need to actually do these validations again. Because why? There's no such thing as a safe robot, only a safe robot applications. So it's based on the applications itself. Okay, do take note of that. Okay, we do have also safety relays. So our PNOZ X and Sigma series, as well as a few other range as well here. So they can actually touch on your safety gates to your e-stops, to your two hands or your light curtains and all this is also able to function as well. And we do have a new product called My PNOZ, which is launched not long ago. So this one is actually functions up to 2 to 16 functions you can actually put into this. This is actually a customized kind of safety relays that you can actually put on. So I'll use this to explain to you. So you create using this My PNOZ creator online, and then using that to simulate what you want. And once you are happy with what you have, we can also help you with this. then you let us know. Then we will actually build for you, and we will actually set up and test it for you. So we will, after testing everything, we will send to you in one box. So what you need to do is just to install it. It's a plug and play system. Then there will be less wiring and also less space in the cabinet needed. And most importantly, you do not need any software after that for any starting up or even replacement of modules. So for this, I also have an application stories. So this is a 1 to 4 emergency stop in series kind of application. 2 safety inputs, so it's a light curtain and safety door locks, and 2 times semiconductor output is needed. So they are currently using a brand X software program safety relay, but customer needed something easy to install because the worker is unskilled and they don't want a program. So what we offer to them is actually these solutions where you can see this is the e-stops, and this is the safety light curtains and the safety doors itself with 2 outputs of semicon. So this is just a very simple kind, thereby they can use this to replace the programmable safety relay. Okay, so there is also a PNOZmulti 2, which is actually a programmable safety relays. This is actually a top selling for us. So this is actually programmable, as I mentioned. So it comes to a program. So you actually up to performance level E, and it's according to ISO 13849, all this. So it's also very easy to configure. And if let's say you have something that you want to change the program and all this, or you have a very complex system, this will be highly suitable for you. Okay, we do have some application for that as well. So we do have a laser exposure and inspection machines for PCB processing. So they are using a PNOZmulti 2 that comes with a motion monitoring and analog modules, and of course adding in some e-stops and also safety covers and doors for these applications itself. Okay, we do have some application stories also for semicon. So we have a semi-turbo processing manufacturer itself, and this is a machine for horizontal ovens for 300 mm wafer. So they are using actually our PSENscan, which is our non-contact door switch, and also a PNOZ which is our relay, safety relay. And we do have also semi-inspection X-ray manufacturer that is using our PNOZmulti 2, our PSEN code, which is one of the non-contact, our PSEN op, which is our light curtains, and also PSEN S lock, which is one of our door locks. And we have also applications in the semicon for a special application such as gas. So there's a gas cabinets, which is for safety device for safely supplying special gas for the semicon industry, FPD, LED, and also solar manufacturing processes at a constant flow rate and pressure. And the requirement for most of these products are installed in gas environment. So some of these devices are required to meet the explosion-proof designs. So one of these, the products we actually managed to sell to them is actually our PNOZmulti 2 and also our PSENscan. Okay, it's a non-contact magnetic switch, but this is X-rated. So this is something that meets the customer's requirement as well. So as this is one of the pictures of it. Okay, so I've come to the end of our presentations. Do take note, we are the ambassadors for safety. We make sure that your staff, your company most valuable assets can work safely and free from injuries. Okay, we will move on to Q&A sessions. So I have received some questions. Okay, what if robot is integrated inside the electronic machine? Okay, do we need to have risk assessment? Yes, for sure. We need to have a risk assessment for the robot itself. So this, according to this, okay, the whole machine need to be going through risk assessment according to ISO 12100. However, the robot parts need to be referred to the standard of ISO 10218-2. This is for the robot system itself. Okay, this standard will explain how to assess the interface between robot and also the surrounding machine parts. So did I answer the question? Yes, most of our products is similar to Rockwell and Keyence. However, we provide services and also trainings. That's the difference between us to most of our customers. Okay, for semicon machines, they also refer to 12100 and 13849. So they actually covers this as a reference. So they actually refer back to these standards for their risk assessment as well. So you do need to, once you use the SEMI as a SEMI standards itself, you have to refer also back to these ISO standards. You can actually check there's a reference on this, on their document itself that states that reference back to this 12100 as well. So it's the same. So they are usually using the same standards. There's no different standards for them to do the risk assessment. Any more questions? Okay, if not, then I will hand over to Augustine for his presentation itself.
Some indication. Okay, good. Good morning, ladies and gentlemen, and also to our friends from Australia and New Zealand. Good afternoon. Okay, my name is Augustine. I'm the sales leader for Baumer Singapore. I'll be the presenter, okay, the second presenter for today. Okay, thank you very much for joining us today and staying with us, okay, for this webinar. Without further ado, let me go into my presentation. Okay, I will give a brief introduction of Baumer, okay, for the benefit of those who are unfamiliar with Baumer. Then I will move on to talk about the electronic semicon history, the trends, some of the voice of customers. I will talk about the big picture from Baumer, provide some application examples, and I'll do a summary. Baumer is a Swiss company, and we are headquartered in Frankfurt, Switzerland. An hour ride by train from Zurich International Airport. Baumer have around 2,700 employees globally and is located in 19 countries and 39 locations. So this is the picture of the Baumer headquarters in Frankfurt. Okay, Baumer is a sensor company. Okay, so sensor in Baumer's term does not just talk about proximity sensors. Okay, in Baumer world, sensors includes not only the proximity sensors, the measurement sensors, the advanced sensors. It also include the force and strain, include the precision switch, the process sensors, the encoders, both the industrial encoders and heavy duty encoders, And last but not least, the industrial cameras. So in Baumer world, sensors mean much bigger. Semiconductor timeline. Way back in our grandparents' generations, we have the first transistor, and the radio transistor was invented. We have a digital clock. The first memory RAM was invented way back in 1970s. The first arcade games, I'm not sure how many of you may recognize this. And we have the personal computers, the 086, 286, 386, 486 computers. And of course, the mobile phone as big as 1 liter water bottles. Moving on to today's flip phone from Motorola, with the smartphones. In today's context, we have not only from plasma to LCD to OLED, TV, monitor displays, supercomputers. So electronic semiconductors have evolved greatly over the many decades. With the evolutions, also come with the advancement in the chips and all the chips handling process, packaging process. For the wafer level packaging, over the last 10 over years, you can see the development of the wafer level packagings, the mobile phone processors, the CPU and the GPU chips getting more and more powerful, and even the high-end mobile processors is more powerful than some of the personal basic level entry computers. Okay, the advancement in the radio frequency chips, the communication chips, the Bluetooth was invented less than 20 years ago. And Wi-Fi standard have improved so much. Okay, we also talk about moving on from 3G to 4G. Now we talk about 5Gs. So the chips, okay, the advancement of chip, the packaging have changed. Even the automotive, all the aircon control, temperature control, fan control, the car control system, the console. Now, all cars come with touchscreen or displays. So the chips behind all this are all the semicon. So what do we hear from the end user, our customers? From the foundry wafer process to the back end, the wafer size have been moving up to from 200 to 300 mm, and in the development of 450 mm. The node size have go down of 60 nano all the way now to 10 or less. So the equipment that is used to manufacture have to first talk about downsizing, we talk about being able to handle bigger wafer, able to handle thinner wafer, even the functionality of the machine have to be improved as to handle the more advanced chips down to the end of the back end, the packaging process from standard die bonder to fixed chip bonder, 3D bonding, up to the PCB level, from two-layer PCB to multiple layer PCB, from standard through-hole mounting to SMT mounting and ahead. So there is a need to reduce the product start time. Now we talk about high mix, low volume. We talk about fast changeover. We talk about quality improvement, machine OEE. Talk about parts availabilities. Before the COVID, everybody talk about JIT. With the COVID, JIT will change because with the global shortfall in chips, it proved that JIT cannot handle such global situation. Here on the process control, systematization of process know-how, the entire line process control, with failure prediction, predictive maintenance, IIoT, Factory 4.0. So all these are what we are hearing from our customers. So what does Baumer see ahead? In today's world or yesteryears, that is the type of connection, the connectivity, the control, the communications for all the devices in the machines. And Baumer sensors is also part of the equations. It used to be just either digital or analog. In some sensors, we talk about serial communication, the RS232, 485, 422, those higher advanced sensors talk about TCP IP, and moving on to field buses. But what about in the future? With cloud computing, with real-time monitoring, with predictive maintenance, with remote monitoring and commissioning, the world will change. So Baumer is also changing too. With I/O links, with OPC UAs, and all the various communications allow Baumer's sensors to be incorporated in tomorrow machines for the future needs. With I/O links, which is the trend, the in thing of today, the benefit from adopting I/O links with Baumer's sensing solutions, the easy identifications by the controllers, so whether it's a PLC or PCs. And I/O link is a global standard with the I/O DD file available in your websites, where any user can download and easy integration into their programs. The parameterizations give us the benefit to quickly adjust, install, or replicate. So when sensor failure, you replace the sensors, you need to recall or try to find the old back the notes. What was the parameter set in the 40 sensors? But with IO-Link, all this include replacement, the parameter is being pushed from the controller down to the sensors. So it's typically plug and play on replacement. They give a lot of flexibility because of the ease of customization, on the fly parameterization customizations. So no stoppages, machine become flexible, very easy to use. And with Baumer, the counter functions even helps the PLC programmers in terms of doing the basic counting application within the PLC ladder diagram. On the process data, adoption of newer IO-Link standards and higher speeds up to COM3 with the data bits, 8 bits up to 32 bits. We have to be able to read up our measurements value instead of just present or absent, yes or no, okay, not okay. But all the measurement values can be read. So the machines or the SCADA level can have having the big data analysis. You can do a lot of status monitoring to improvement. That of course in conjunction with the dual channel, where both the measurement data and diagnostic data can be sent up to the masters, IO-Link masters. So with the diagnostic data, it will be able to fulfill the needs of predictive maintenance and always monitoring the health of the sensors of any field device in the machines in the production line. So with the adoption of the IO-Links or all the newer communications connectivity like OPC, we move on to the offering from Baumer for the various semicon application or machineries or process. On the back end, the molding machines. You can have the temperature sensors, pressure sensors, the temperature to monitor the temp consistency, and the pressure sensor to monitor the consistency of the pressure when pumping the liquid mold into the die, into the injection molding mold, into the cavity. Of course, we also offer the cavity pressure sensors to enhance the monitoring. We also have the strain probe on the clamping force, and also the membrane load cells to check on the overall qualities. Apart from the sensors, the level sensors in the tank, apart from the sensors used, and also the encoders. So Baumer solutions is comprehensive for such molding machine applications. In terms of feeder technology applications, in the back-end assembly, whether at the PCB level or to the device assembly, electronic device assembly level, or at the packaging levels, there is always some form of feeding technologies involved, mechanism involved. In this illustration, we have the vibratory blow with the auto feeder. The various Baumer sensing solution can be adopted to enhance, to improve the overall monitoring, controls, and productivities. The ultrasonic sensors typically for level controls for both the feeder and the tanks. The encoders on the conveyor feedback, tracking, object trackings, or even to use to trigger the cameras, the smart visions, the variations. And of course, the variation is used to check product quality, cross quality, orientations, alignment, positioning, sorting. We have the sensors. The photoelectric sensors is used to detect the presence of the object being fed at the end of the feeder to the feeding track, whereas some people adopt the fog sensors, so true beam for ease of mounting, okay, or okay, it's easy to mount. You do not need to align the receiver and the emitter. So Baumer has a comprehensive solution on the feeding technologies to enhance, okay, and to improve on the machine OEE. Moving on the stage, SY stage, which is very common in all the handling machines. We have the offering of the precision switch, the MICOM, to allow the precise homing of the stage. This is also act as a feedback loop for the servo motors. Next, we have object sensings along the machine's handling, whether it's we talk about lead frame handler, tray handler, strip, a chip handler, wafer handler, or we go up to the die level handler. Photoelectric sensors are typically very common and is a necessity to detect the present absence, and for those measurement type, to detect the position, the height of the chips of the die of the parts. So Baumer O300 laser class background suspension models, they offer the smallest spot beam in the market at 0.1 mm. That is even smaller than the fiber optic sensors, the smallest spot beam. Baumer range of industrial cameras is also widely used to help customers in terms of quality controls. In the electronic semicons, machine vision is widely used on the machineries used to manufacture from the wafers down to the complete chip. So Baumer offer extensive range of cameras from the VCSG, the common entry series, covering the full spectrum from VGA all the way to 20 meg to high clarity mid C-mount sensors, high speed models of the LSG, VRG G series, typically used in the wafer level inspections. That have a resolution support up to 65 megapixels. So Baumer range of industrial camera definitely will be able to meet the requirements of all the semicon users. We have the displacement sensor or distant measurement sensors. The new generation, the OM20, 30 and 70 series. The 20 series is the smallest all-in-one distant measurement sensor in the market. What do you mean all-in-one? It means that the amplifier is built into the sensors. So this is the smallest in the market of today. And it support I/O links. So all the new sensors come with I/O links. Whereas the OM70, the biggest, support few buses. And this series of sensors not only have high speed, a very fast response time, and it also can achieve very high accuracy of less than 1 micron, repeat accuracy. And last but not least, the robotics applications is also very common in the electronic semicon industries. Baumer have the SF or SC900 series, which is part of the UR Plus partner. They come with the UR Cap apps to be installed onto the UR robot controllers for ease of integrations. Of course, apart from UR robots, the smart grid function that is come with even the standard 700, 800 series of the variations. They will be able to support all the robot brands when in terms of calibrations, alignments to the robots. For the 900 series, it comes with the UR Cap apps for UR robots. So the variations within the smart cameras will help to be the eyes of the robots. So it will become a vision-guided robotic solutions instead of just a pure robot pick and place on the fixed pick and place position. Of course, the robots, instead of using cameras, certain applications uses the displacement sensors, and for Baumer we have the OX200 series, the profile sensors. With the profile sensors installed together with the robots. So come to pick and place application where the height of the objects varies in height. The profile sensor will be able to output the Z information so that the robot can move down to the right level to pick up the objects. Because the OS200 series is also a profile sensors. And so the OSM for multi-tools category offer a range of smart measurement tools. So at the same time as the sensors provide the Z information to the robot for the pick and place, it is able to also do measurements with the height measurement, the thickness, the width, the circularity, the center positions, and other things, or the angle of the object. So that kill two birds in one stone. And so this is how Baumer solution will help to enhance and improve the quality control or the productivity of the customer machines. And moving on to the summaries. Baumer sensor solutions can offer reliabilities. For the photo sensors, laser measurement sensors, they are able to detect very dark objects. They work well, be able to detect. Even if the object changed from dark to white to bright, it will work. So it's very reliable. And in today's environment of the LED lights, the LED light become a nuisance to the sensors because a lot of false detections. And Baumer range of photoelectric sensors have extremely high ambient immunity, so it means that it will work well. The sensor will perform robustly, consistently. For the ultrasonic sensors, it comes with the PIC film protecting the transducer. So in the semicon, every time they have to do a alcohol wipe down. And we heard from the customer that the transducer of the ultrasonic sensor always will get damaged after some time due to the wipe down procedure. Okay, so the PIC film routed over the transducer help to make it robust, help the sensor to be durable. And of course, our range of products, especially those full metal housings, which is very suitable, and not only for F&B, but in electronic semicon context, especially in a clean room class 100 and below. It is preferred to have full stainless steel without any paint, without any imprinting, or powder coats to prevent contamination. So this full stainless steel series come with Protect Plus, which is further enhance the durability of the sensors. So Baumer also offer a very high level of usabilities. All our sensors, for example, they offer a one box design. So across the O300 series, the full range of sensors share the same design. So one common brackets can be used across the full series. Okay, and of course, we have the Q target, Q teach function built into the sensors that allow precision alignment of the optics, okay, the light source and the optics. So in terms of replacement of the sensors, the optics will be still shining at the same spot. So you do not need to have a bracket with a S, Y adjustment to align the sensors. And with the Q teach, the ease of teaching the sensors using the any ferrite material, like in this case, an Allen key, to trigger the teach. And the teach itself is smart enough to have multiple levels. So instead of having to connect your sensors to a PC to do programming. And the advanced sensors support web server functions. So without a need for installing software into your PCs, you just need to use a web browser and you can configure the sensors and even monitor the sensors. In terms of compactness, a Baumer portfolio, Baumer strength is in miniature, sub-miniature sensors. From the inductive to the photoelectrics, and to the laser measurements, or even to the precision switch, they are all very compact, very small. So it fit into tomorrow needs, okay, of our customers, where the machine get smaller or the same size of machine now doing more functionality. So space become a premium. Everything have to be string, not only the electronic component string. Okay, the sensors in the machines also have to shrink in order to fit the needs. In terms of connectivities, the Baumer range of sensors, encoders, depending on which product. If we support field buses, the various field buses, all new sensors come with I/O links, right? And for future needs to the cloud, to the SCADA, the OPC UA. So Baumer sensor solution, it offers all these benefits and help our OEM customers to deliver their machines for the end users based on their needs. For the semiconductor metricing process, regardless whether it's on the foundry level, all the ways to the back-end chip level or to the PCB level, Baumer have the solution for you. As we end my presentation today, please remember, Baumer is your partner for smart connected sensor solution. I'd like to thank everyone to stay with me for this. Now we are open to questions. Okay, I see the questions for machine risk assessment. Okay, this is the previous questions. Any questions from the floor? Feel free to ask. And for some of you who may have suddenly thought of question for Thomas, you can also ask. Thomas is still around to answer your questions. Encoders have safe. For encoders, there are certain range of encoders that come with safety, supporting SIL 2 or 4. So you have to know your requirements in order to propose the right encoders for your application. Safety fault sensor. Okay, Baumer do have 4 sensors, 2 different sensing methodology, but unfortunately we do not have one that come with safety. Any more questions from the floor? Okay, if not, I'll hand over to Irene. Okay, I will seek everybody present support, okay, to help us to do the survey. So we appreciate your feedback. Okay, with your feedback, we hope to do better in our next webinar. Irene, hand over to you.
Thank you, Thomas and Augustine, for the great presentation. And that brings us to the end of the webinar. Thank you all for attending. We hope you have learned and enjoyed this presentation. If any one of you have any questions after the webinar, do feel free to contact us and we will come back to you soon. Lastly, I will flash the survey on the screen. We will appreciate you to fill up before you leave this webinar. Your view is important to us. It helps us to improve ourselves for our next event. Thank you, and we shall see you all again. Stay safe. Goodbye. So this is the survey. Please help us to fill up your feedback. Thank you very much.